Hi, in this video we are looking at question 4 from the 2019 ordinary level physics paper and the Living Certificate. So this is a question in electricity, and we were told that a student performed an experiment to measure the resistivity ρ of a piece of nichrome wire of length L, resistance R and diameter D. And we have a number of tasks that we need to carry out in order to get our marks. So let's get to it. So first of all, we are asked a number of questions related to the equipment. So what is the equipment that we use to measure the length of the wire? We can say that we used a meter stick, or a ruler. We have to name the instrument used to measure the resistance of the wire. Name of that instrument is ohm meter. And finally, we need to name the instrument used to measure the diameter of the wire. So that would be either a micrometer or vernier caliper. These three instruments were required for this experiment. Now, in this experiment, the student took three measurements of the diameter. They are listed in the table. And we have to use the data to calculate the average diameter of the wire. To calculate the average diameter, we need to sum all the measurements. So 0.00024 plus 0.00028 plus 0.0023, and divide the result of this addition divided by the number of the data points, and in this case we have 3 data points. So if you carry out that calculation, we'll get that the diameter in meters is equal to 0.00025 meters. Next part of the question is asking us to calculate the cross-sectional area A of the wire. Wire has a circular cross-section, which means that we can use the formula for the area of the circle to find this cross-sectional area. So area is equal to pi times r squared. Now r is the radius. We don't know what the radius are, but we know that radius is equal to the diameter divided by 2. And we can use this into our area equation in order to get our result. So to do that, let's substitute d over 2 for the radius. Area is equal to pi times diameter over 2, all that in the bracket, and let's square it up, and that turns into the formula of pi d squared over 4. And if you substitute the values, so 0.025 into our d, we'll get that the area is equal to 4.9 times 10 to minus 8 meters squared. Quite a small area, but obviously that has to be true because it's a narrow wire. And finally, we have to use the formula ρ equal to Ra over L to calculate the resistivity of the wire. So we know that ρ is the resistivity, R is the resistance of the wire as measured using the ohm meter, A is the cross-sectional area of the wire as calculated by us just a second ago, and L is the length of the wire as measured using the meter stick. So we can substitute all the values into our equation. We get this type of formula. ρ is equal to, we substitute 22.8 for the resistance. We substitute 4.9 times 10 to minus 8 for the area, and we divide all that by 0.98 meters. 0.98. Punch it into your calculators and you'll get the result of 1.14 times 10 to the power of minus 6. Very important, unit in this case is ohm times meter. So for each meter of the wire, the resistivity for this particular wire is 1.14 times 10 to the minus 6. If you get all those answers, you should be well capable of getting full marks for this question. Thanks for watching, and I'll see you next time.